Shit. Okay. So this is about the processor.
Okay, sir.
Okay. This is about the processor.
Okay.
Next one. Memory.
Memory. Yeah.
Memory is of two types: primary
Primary.
and secondary. Primary memory is also called as temporary memory,
Hmm.
and secondary memory is also called as permanent memory.
Memory. Yeah.
This temporary memory example is RAM. RAM stands for random access memory.
Hmm.
Permanent memory
Yeah.
is hard disk.
Hmm.
Now, coming to RAM, RAM is temporary memory.
Hmm.
RAM is volatile. It means volatile means
Well,
it requires a constant power supply to store the data.
hmm.
Requires constant power supply to store the data.
Hmm.
So if it is a temporary storage, if it is a temporary memory, if it requires a constant power supply, are there any uses of RAM so that why we are using RAM?
Hmm.
These are the only two things that we know, but there are some more points about RAM.
Hmm.
That is, whenever we open any application, like I had opened Notepad, I had opened running GoToMeeting, there's some browser running.
Hmm.
There will be some configuration files or configuration settings regarding this applications.
Hmm.
What process has to start? Is there any service to be started? Are there any files to be loaded additional to this application?
Hmm.
So these all things will be present in some configuration settings, configuration files.
Hmm.
These files are present inside your hard disk.
Hmm.
Present inside your hard disk,
Hmm.
and those files will be copied to your RAM,
Yeah.
and those files will be read by the processor.
Hmm.
Processor can read instructions faster from RAM
RAM.
than from hard disk. So that's one point. Contains instructions about the applications you open. Another point is allocates memory to different applications. I open Notepad means it will be, or it is occupying some space. This GoToMeeting is running on, means it is occupying some space. Browser is running on, it means it is also occupying some space. For every application that you open or the application that is running in the background, they will be occupying some space and memory space, not storage space. They'll be occupying some memory space, and that memory space will be allocated from RAM.
Yeah.
And yesterday we had come across one point that memory unit will be storing the instruction temporarily. That instructions, sorry, uh, storing the request result
Hmm.
will be stored in RAM. RAM is used to store processed requests or results. Okay.
Yeah.
Now this is some small practical part. If you open Windows Task Manager of a processors, these are the
Processor.
processors that are running in the background or opened by the user.
Ah.
This Chrome.exe, whatever the Chrome.exe you find, it is related to the browser. And the memory it is
Mm.
occupying over here, memory. 47 MB, 117 MB, 10 MB, 15 MB, 1 MB.
Ah.
And this is our
That means
go-to meeting session.
that means it's using RAM,
Yes,
RAM memory.
RAM memory. This is our go-to meeting session.
Sorry,
Go-to
sorry.
meeting, G2M COM, GTM launcher, GTM start, G2M UI, GTM video conference. This is related to GoToMeeting.
Definitely.
And I had opened this notepad, the only over here, this one, notepad.
Yeah.
Okay, like this,
Ah.
one which we have opened, the one which is running in the background will be occupying some memory space.
Ah.
Okay,
Mm.
now in this part, let's say I'm not using this Chrome for an hour.
Mm.
It means this becomes inactive.
Yes,
So
yes,
when it
yes.
becomes inactive, whatever the space it is being, or whatever the memory space being occupied, this Chrome will be moved to a space in hard disk called as a page file.
Ah, it will move back to the hard disk.
Yes, moved back to hard disk in a special space called page file.
Ah.
So that if any new application has to open, it has to get space, memory space available.
For any application you open again. Maybe you
Yes,
want to open another
yes.
one.
Okay. This process of
Yeah, okay.
from the moving the inactive applications from RAM to hard disk is called swapping. And if any application becomes active, they are kept back to RAM. It is called as swap out. Swap in,
Ah.
swap out.
Mm.
Okay, let's write the points.
Yeah, I can try that.
RAM is a temporary memory. RAM is volatile. Volatile means it requires constant power supply to store the data. It is used to store the instructions about the applications we open. Allocate memory to different applications. Processor can retrieve data faster from RAM than from hard disk. Mm, Inactive applications in RAM are moved to special space in hard disk called as page file. The process of moving inactive applications from RAM to hard disk and active applications from hard disk to RAM is called swap out and swap in respectively. Let's see the swap size. In Windows, the page file size is managed automatically.
Mm.
Advanced, you can see here. Virtual memory. The
Virtual
other name is
memory.
virtual memory. You can see it here. It is occupying around 3319 MB, around 3 GB.
Okay. Yeah. Processor schedule.
Yes, currently it is allocated 3 GB of space. Okay.
Now.
It is managed by system automatically. If it needs more page file, it will increase the page file.
Mm. Ah.
If it is not necessary, then it can decrease the page file.
Good job.
Okay. Now, in this RAM, you are having two types:
Mm.
static RAM,
Okay.
dynamic RAM.
And dynamic. Mm.
Static RAM means you cannot modify or decrease the capacity of RAM.
Mm.
Dynamic RAM means you can modify, you can increase or decrease. I'm
Ah.
having it.
That
Yes.
I think that is always happening in desktop.
Hmm. Uh, if I'm having 8 GB, I can add another
Mm.
8 GB. Or if I
To
don't
make it
want 8
system.
GB, I can reduce it to 4 GB.
Mm.
That is dynamic RAM. Static RAM means if I'm having 1 MB means you can have 1 MB only.
Ah.
And most of the times and always, whenever we talk about the system configuration, we say about dynamic RAM only. That my system is having 4 GB of RAM. My system is having 8 GB of RAM. We never speak about static RAM.
Ah.
Example for the static RAM is cache memory. What comes under static RAM?
Ah.
Cache memory.
Caching
Cache
memory.
memory comes under the static RAM. Now in this cache memory, you are having three levels: L1 cache, L2 cache,
Okay.
and L3 cache. L1 cache, L2 cache, and L3 cache. The capacity of L1 cache is around maximum 512 KB. The size
Mm.
of L1 cache is 512 KB, the maximum size. L2 cache is 2 MB. and L3 cache is 6 MB.
6 megabyte.
Yes, 6 megabytes. Now, where does they present? Where are they present? Present inside the processor.
Mm.
This is also present inside
Processor.
the processor.
Mm.
This one near the processor.
Mm.
Near the processor. Okay. Now, why do you use this cache memory?
Mm.
It is used to store the instructions about the application we open. The same work done by the RAM. Cache
Ah.
will also do the same work.
Mm.
Now, processor can retrieve data faster from cache than from RAM. Why it is like this? Compared to
Mm.
hard disk size, your RAM size is less.
Mm.
So you can get the data faster. Compared to RAM
Mm.
size, cache size is even less. So you can get the data even faster. And one more point is cache is present inside the processor. It is present inside the processor. And it works at the speed of the processor. It works at the speed of the processor.
Mm.
That's the reason processor will get the data faster from cache than from RAM, which is written somewhere else on the motherboard. Now here let's take an example over here.
Mm.
Let's say there is a table.
Mm.
On the table, you're having some files,
Mm.
and on the table, you're having some more files, and there is a file cabinet or shelf where I'm having some more files.
Mm.
Now there is a chair and a person sitting on this chair. Now, mm, now, what file this person will open first? The file which is present in front of him, or the file present on the table, or a file present in the file cabinet?
In front of him.
In front of him.
Mm,
So first we will open the file which is present in front of him,
mm,
right?
mm,
If he doesn't find what he needs, then he go for the one which is present on the table, right?
yeah.
If in this also if he doesn't find what he needs, then he goes for the file cabinet. The first one which I had said is cache.
Mm,
The person who is looking for something in files is processor. The files present on the table is RAM. And the last option, the file cabinet, is hard disk. This is the way how the processor will retrieve data. First, it will look at the cache, then comes to the RAM, and last, it will come to the hard disk. Okay?
mm,
Now, coming to dynamic RAM, cache can be considered as buffer with a small brain. It's a buffer with a small brain. Means most of the times cache will be ready with what processor needs.
mm.
Okay, it is somewhat intelligent. Okay, in dynamic RAM, you're having video RAM, SD RAM, RD RAM, and DDR. Again in DDR, you're having DDR1, DDR2, DDR3, and DDR4. EDO RAM stands for Extended Data Out RAM. SDRAM stands for Synchronized Dynamic RAM. RDRAM stands for RAM bus dynamic RAM, and DDR-RAM stands for double data rate RAM. So, how do we identify the different types of RAMs? See, this is SDRAM. It will left. It is to the left side, and this middle. So, these are the memory chips, and these are the pins. We use three things here to identify what type of RAM or to differentiate the RAMs. One is the number of notches. These are the notches. The number of notches present in the RAM, notch placement, and the number of pins present on the RAM. Based on this number of pins or the notch placement or the number of notches, we say what type of RAM it is. Okay. So what type of RAM it is. I'm having two notches, one to the left and one to the middle. I will say it is a SDRAM. If you take this, you're having one notch to the right. This is DDR1. Sorry, one notch to the right, but appears to be in middle. It is DDR2. If it is bit to the right side, that is here. If the pin is present over here, if the notch is present over here, it is called as DDR1. It's called as DDR1. Yes. This one. This is not the desktop type of RAM. It's laptop. This is for laptop. DDR3.
How do you know it's 3?
Here it is there. The notch present to the left side. For DDR3, the notch will be to the left side.
Left.
Yes, based on that we can say it is DDR3.
From the left. If it is right, it is
DDR1. Extreme right DDR1. Appears to be in the middle, DDR2.
2.
Yes. What's this one?
This is.
If you're having a chip in the middle, like this, most of the RAMs we use don't be having a chip in the middle. 4 memory chips to the left, 4 memory chips to the right, like this will be there. But if you're having a chip like this in the middle, we can say it is a registered module. Non-registered and registered. Most of the processor we use is, or most of the RAMs we use is non-registered models, like this one. See, this is a gap over here. This is non-registered. If you're having a chip in the middle, it is registered.
Registered.
Yes. This one. You can see the two notches are in the middle. This is RD RAM. RD RAM.
Yeah.
So of these four RAMs we are having, presently we are using DDR2, DDR3 and DDR4.
Oh.
Yes. We're not having this EDO, SD, RD and DDR1 also. We're having DDR2, DDR3 and DDR4.
Wow.
Now to use this processor, to use this RAM, we need a slot that we call it as RAM slot or memory bank. RAM slot or memory bank. Use it to insert RAM. Now in this RAM slot or memory bank, you are having three types of RAM slots: SIM, RIM and DIM. SIM stands for single inline
Line
memory.
memory module.
Again in this, you're having SIM 30 and SIM 72. In this SIM 30, FP RAM is inserted. In this EDO RAM is inserted. FP RAM means fast processing RAM. RIM stands for RAM bus inline memory module. RAM bus inline memory module. In this, we can insert RD RAM. DIM, dual inline memory. In this, I can insert SD RAM and DDR RAM can be inserted. Now, if you see, for every slot like SIM and RIM, you're having a clear picture what type of RAM can be inserted. If you go for SIM 30, I can say this you can insert only FP RAM. SIM 32, EDO RAM, RIM, RD RAM. But when it comes to the DIM slots, I'm saying you can insert SD RAM and DDR RAM. Now again in DDR RAM, you're having four types. Now, how can you know what type of RAM can be inserted in this particular DIM slot?
I want to ask you one question about CACHA. CACHA is a static RAM, but
Yes.
CACHA is present in all computer.
Yes.
Right?
Yes.
But people don't talk about CACHA.
Yes.
Okay, continue. I understand.
So here, how do I know what type of RAM I can insert in this particular DIM slot? SD RAM or DDR? Again in DDR1 or 2 or 3 or 4. How do I know? Here in the previous things, SIM30 means I can say FP RAM, SIM72 means DDR RAM. Only one particular type of RAM is inserted in each slot. But here, it is not that case. I'm having multiple RAMs. Now, how can I get this is, let's see. Okay. If you see the slot, there is one separator over here. A small separator. Depending on the separator space placement, whether it appears to be in the middle, whether it appears to the right, whether it appears to the left, whether you're having two separators, depending on this, what processor you can insert will be present. Now here, it appears that it is to the middle. Although it is not to the middle, it appears that it is to the middle. It means in this you can insert DDR2.
DDR2.
Yes, DDR2. So here there is some example over here. See how the RAM is inserted. There are two separators, one to the middle and one to the left. It means this is SD RAM type. Okay, like this we can say. You can count the number of pins. There will be number of pins noted over here. Okay, based on that you can say. This kind of knowing what RAM can be inserted in that slot is for the beginners. It is for the beginners.
It's for the beginners.
They will see the voltage of the processor socket, voltage of the RAM slot, or the separators, number of separators or a separator placement, or the number of pins. But the experts or the experienced people who are working on these motherboards daily, you just say the motherboard model number and they come up with what type of RAM is in the motherboard. For example, if I say 815 motherboard, it is DDR1, 845 DDR1, 945 DDR2, G31 E2S DDR2, G31 another model DDR3, G41 E2S DDR2. Like this, model number, and they know what type of RAM is inserted in that motherboard. This comes with experience. When we see a lot of boards daily and the RAMs inserted, we can say, okay, this is the model number, and then this is the motherboard, sorry, this is the RAM type that we insert. Okay, so this is about memory. Yes. Okay. We discussed about how the storage capacity is taken, how it is measured. There is another point about the speed of the things. Speed is measured in megahertz. Speed is measured in hertz, which is 1 cycle per second. 1000 heads is 1 kilohertz.
Kilo.
1000 kilohertz 1 megahertz.
Okay.
1000 megahertz 1 gigahertz.
Okay.
Presently we are at gigahertz only. 1000 gigahertz 1 terahertz. Like this we measure the speed. Hertz.
Speed of any components.
Yes. Whether it's RAM or processor or anything.
In the
Processor's present speed is around 1.6 gigahertz to 2.0 gigahertz. RAM present speed is around 2.3 gigahertz or 1.3 gigahertz or 800 megahertz. Okay. Next point regarding this RAM is when you start the system, sometimes the system will show something like single mode, dual mode, flex mode, and so on. Working at single mode, working at dual mode, working at flex mode, etc. Single mode means, if I take this one example, single mode means I had inserted only one RAM in one slot. You're having only one RAM. That is single mode. Flex mode means you can see color combinations over here. So in this black color slot, I had a RAM with capacity 2 GB and speed 667 megahertz. And in this blue color slot, I'm having a RAM of capacity 1 GB and speed 667 megahertz. Or let's go with black one only. When you're having different capacitors or different capacities or different speeds in same colored slots, it is flex mode.
Same color.
Same color. It is flex mode. Let's say even if you had same capacity, same speed processors in different color slots, it will be single mode only. It will be single mode only. If you are having same capacity, same speed, RAMs, same colored slots, that will be dual mode. If the system is running at dual mode, if the memory is running at dual mode, then you can have optimized performance. If the memory is running at flex mode, the performance may decrease a little compared to dual mode. If it is running a single mode means it is a base. It's a base performance. Okay. So these are the. Which one is better is dual mode. If you're having dual mode, it is better. You're having two RAMs with same capacity, same speed, in same colored slots. and you're having extra RAM, additional RAM, which is also of same capacity, we say it is running in flex mode.
Flex mode.
So in this example, in this the picture example, either you should have 2 RAMs or you should have 4 RAMs to get maximum performance. And it should be of same capacity and same speed. Okay. And it also depends on the motherboard, the speed of RAM it supports. Depending on your motherboard model, we have to choose the speed RAM. If it supports 667 megahertz only, and you're using 800 megahertz, that RAM might not work on your motherboard, or if it works, it might not work for a long time. Okay. So this is for today's class. Yes.
So nice.
Yeah.
Okay. Thank you so much, sir.
Yes. Today is done.
So see you tomorrow.
Yes.
Second class.
Yeah. Bye.
All right. Bye. Thank you, sir.
Okay.
Yes.